implies Q. Classical logic says if you have both of them, then you have Q. So if you think from two opposite things you prove the same thing, then it must be true. You're happy with classical logic. If you think two opposite things can't both give you the same result, then you're a connexive logician, which is a different sort of logician than we've talked about so far. I'm a heretical connexive logician, if you need to put a label on me. Okay, so this is an arrow connected. There's nothing over here. This arrow is anything we can work on, unless you want to just double this. There's no point in doubling when you only got one formula anyway. That just makes your problems twice as big. So we're going to go P implies Q becomes our premise, and not P implies Q implies Q becomes our conclusion through not R. Oh look, we've got an arrow on the right. Let's do that. So that means that we add to our premises not P implies Q, and that gives us Q. This is looking a little more like a normal sort of thing we might work with. Okay, we've got an arrow on the left. Let's just choose this one. We're going to break it down and get two different things. I think I want to double this because I'm going to have two different conclusions. I might need to double that. Maybe I won't. I'll try it without doubling. We'll see what happens.
Sorry, from the first line bottom up. Are we using, arrow right? Yeah, okay.
Yeah. Okay. It just feels, because I'm splitting things up, I need to have more conclusions. But let's work on this. I'll leave a gap in case we need it. So this P becomes the conclusion of some argument, and this Q becomes a premise of some other argument. Now this conclusion here is going to have to go here, I guess. And what's going to go over here? I guess this not P implies Q will have to go over here. But not P implies Q is not going to give me P by itself. I'm going to need something else. So I think I want to have this Q being double, but it's not quite clear yet. So let's push on and we'll see where we need it. That side's good. Over here we're going to need something else. But let's break down this Q, this arrow, and we'll see what we need, and we'll come back and we'll fill it in. So that is an arrow on the left. We left a gap in case we need to copy. That's the arrow on the left. This is the potential copy if we need it, I guess. So this breaks down to a not P being on the right of something. And I guess our P is going to be on the right of this. And this Q will be on the left of something. So we need to have a Q in our conclusion for this to work. So if we have an extra Q here, that means we've got an extra Q here, that means we've got an extra Q here, which means we have to have copied our Q's here. See if we go back and make it all fit in. So this is, we're going to copy on the right one of our Q's because we needed it up here. I could kind of feel it was needed, but I couldn't explain why. And over here I'm going to take my not P, put it on the other side, and that's going to turn out nicely too. Got rid of the negation on the right. Okay, so that one I think was okay. Once we got to there, we realized we needed a Q. We could trace we had a Q earlier on. We just copied the Q down until we had the extra Q we needed. That's the sort of technique that you start developing. Then after a while, you get to this sort of point and think, I feel I need an extra Q. I don't know why, but I feel it. I just worry. And then after a couple more years after that, that becomes a reliable feeling, and then you can start using it safely. In the meantime, just leave a gap and see if you need it. So that was E15. Any questions on that? It was mainly following the arrow.